In this video, we're going to look at how to calculate the volume of composite shapes. Now, composite shapes are basically any shape which is made up of one or more shapes. So let's have a look at the first example. A pencil is in the shape of a cone and a cylinder. So that's what we mean by a composite shape. A shape is made up of two different parts here. We have a cone at the end, this small part at the end, and a cylinder, which is the rest of the pencil up to about here. And we are asked to calculate the volume. Now, to do that, we just need to do the cone and the cylinder separately, and then at the end add them together. So let's start off with our cylinder. So volume, and instead of just writing V equals and then the formula for a cylinder, I'm going to write V cylinder. And that way, when I'm looking at my working and need to look back at any part of it, I know which part's which. So the formula for a cylinder is one you need to know off by heart, which is pi r squared h. So if you don't know that off by heart, you must make a point of learning it. Next part is to substitute into that. Now, in a composite shape, you really need to pay attention to the dimensions you're given, because there might be dimensions on here that aren't relevant for this particular shape, or sometimes you need to do some calculation in order to work out the lengths of things that you need. The cylinder, remember, goes from here only to this point here. So the 10 centimeters is not the cylinder, it's the 9 centimeters that we use for our cylinder, or this length here. Radius is the radius of the circle. Now the circular end of this cylinder is here, so the radius, remember, would be from the centre to the top, so half of this diameter. So we're going to use a half, so that's pi times 0.5 for our radius squared times h. And remember, the height of the cylinder, we measure it as the distance between the circle at this side of the cylinder and the circle of this side. So the height of this cylinder is this 9 here. So pi times 0.5 squared times 9. We're going to then type that into our calculator, and we end up with 7.07, and that is cubic centimetres. Now we've worked out the volume of the cylinder, we've effectively worked out the volume of just this part here. We now need to look at the volume of the cone at the end, so this section here. So if I look at the volume of this, we're going to again write out our formula. This time it's not volume of a cylinder we're looking for, it's volume of a cone. So I'm going to make sure instead of just V equals, I'm going to put V cone, so I know which part's which when I come back to it. And that is 1/3 pi r squared h. Now that's a formula for an at5, which will be on your formula sheet. So a third times pi times r squared times h. Again, in a composite shape, you've got to really take your time making sure you've got the right value. So the third is part of the formula, so is pi, and the radius squared. Now the radius of this cone is going to be the same as the radius of the cylinder. Okay, the radius is the distance from the centre of that circle at the base of the cone to here, which is 0.5. So we're going to put that in 0.5 squared for radius squared. And then the height of the cone, don't mistake that with the height of the pencil. The height of the cone is the distance basically just from here to here. So as I said, a bit of calculation will be involved here. We know the entire pencil is 10 centimeters long. We know the cylinder part of that is 9 centimeters long, which means the cone must be the difference between the two. So 10 take away 9 basically means the cone is 1 centimeter high. So times 1. We're going to type that into our calculator. Remember, 1/3 is just 1 divided by 3 times pi times 0.5 squared times 1, and we end up with 0.26 cubic centimetres. And then what I need to do is to get the volume of the whole of the pencil here, add the cylinder and the cone together. So add this answer and this answer together. Now when adding parts together, I'll generally use the word total. So total equals 7.07 plus 0.26, which comes to 7.33, and we might just round that to 1 decimal place, because most of my working there was to 2 decimal places, so 7.3 cubic centimetres. We'll now move on to another example of a composite shape. This time we have here a plastic model of an ice cream cone, and we're asked to calculate the volume. Now, again, it's composite shape. It's made up of two shapes you should already be familiar with. At the bottom we have the cone, and at the top we have a half of a sphere or a hemisphere. So what we're going to do is we're going to calculate each of them individually. So let's start off with the hemisphere at the top. So we're going to write V and we're going to label it properly. So hemisphere, and that's equal to, now the volume of a sphere, remember, is given to you on your formula sheet, so that is 4/3 pi r cubed. Remember, be careful copying that formula out. And this though is a hemisphere, it's half a sphere, so if that's a whole sphere, then we need to adapt the formula slightly for a hemisphere, so it's a half of that amount. So let's start to put that together. That half of is just a half times 4/3 times pi times the radius cubed. Now remember, when you're looking for radius or diameter, you've got to double check that you've got the right one. The radius, remember, is the distance from the centre of the sphere to the outside. So the radius is only from here to here. This 70 is from all the way across. So that 70 is actually the diameter. The radius will be half of that, so the radius is 35. So that's 35, and remember, that is cubed. So typing that into our calculator, remember, it's as simple as 1 divided by 2 times 4 divided by 3 times pi times 35 cubed. And when I type that in, we end up with 89,797.19 cubic centimetres. The next part is to look at the volume of the cone at the bottom. So volume of cone is equal to, and the volume of a cone formula is 1/3 pi r squared h, and we start to substitute into that. Now, there's another thing in this question we need to really be aware of, and hopefully you noticed that at the start we have here a unit in centimetres, and we have here a unit of metres. So we can't work in these mixed units, we need to decide on one. Because I've already done the first part of the question and I used 35 centimetres here, that means I'm pretty much working in centimetres now. So that 2 there, I'm going to need to change that into 200 centimetres, so I'm consistent throughout my working. So that 2, I'm going to change to 200 centimetres up at the side there. So when I come now to do this, that's 1/3 times pi times r squared. Now the radius again is the same, it's the same circle for the hemisphere as it is for the cone, so the radius will also be that 35 centimetres, so 35 squared times h. Now again, we need to be a little bit careful here in these composite shape questions, because it might be very easy to look and say, well, the height of that shape is 200 centimetres, but that 200 represents the cone and the hemisphere added together. We just want to know what the height of the cone is. Now the cone is only going to be part of that 200. So how do we work out, what the cone is on its own? Now it comes down to this idea of radius, and it's quite common to have it in these sorts of questions where you need to think about radius in more than one direction. So we've thought about the radius already going from the centre to the outside as being 35, but remember, radius of a sphere can go to any part of the sphere. So from the centre to the top here, or the centre of that circle to the top of the sphere, would also be a radius, so it would also be 35. So if I start to mark that off there, then it's 35 from there to the centre here. And if I take that away from the 200 that I have here, so 200 take away 35, that's going to leave me with 165. It means that the length from here down to here will be 165. So the height of the actual cone, the height of the cone is 165. So that's what I'm going to use in my working for the volume of a cone. So 165, and then I'm going to type that into my calculator, and I end up with 211,664.805. Now, the last part is we're asked to work out the volume of this whole thing. I've worked out the volume of the hemisphere, I've worked out the volume of the cone. The last thing is just to add them together. So total volume equals, and I'm basically going to have to write down those two values. So 89797.19 plus 211,664.805. Adding them together gives me 301,461.995 cubic centimetres. Now, with this question, you could have also used metres throughout. So if you recognise straight away that this 70 centimetres and this 2 metres weren't matching in terms of their units, rather than do what we've done in this example and changed the 2 metres into 200 centimetres, so both are in centimetres, you could have equally changed them both into metres. So you could have left this as 2 metres and change this to 0.7 metres by dividing by 100. All of the working would be the same, except you'd be using metres instead, and you would therefore need to remember your final answer would then be in cubic metres if it's metres you've used throughout. But otherwise, it's the same question.